So, question 3, classic differentiation question. The first part is an easy one. You'll see this in almost all the differentiation questions that you come across. And the first thing I would do with this question, you don't have to do this, but what I would do is just change this slightly. Change it so that you get v equals 1/4 of t cubed minus 3t plus 5. There we go. So then it just gives you a slightly easier way of doing the next part, which is to take the power of t, there, that 3, times it by whatever's in front of the t, in this case 1/4, and then take away 1 from that 3 there. So let's do that now. You get dv over dt is equal to 3 times 1/4, so 3/4. Okay, let's go back one. There we go. 3/4 of t. 3 take away 1 is 2, so 3/4 t squared. Do exactly the same, although it's not as apparent for this one here. The power here, you can imagine there's a little power 1 there for the t. So 1 times minus 3 is minus 3. And then take away the 1 from that t so you don't write a t there. That's why the t disappears there. And then this plus 5, well, that's got no t's there, so 0 times 5 is nothing. So there you go, that's the answer to the first part of the question. Easy as you like. Right, let's make some space and move on to the second part. Here we go. Right. BI, find the rate of change of volume in meters cubed per second squared when t equals 1. So this here, I know it might look a little bit strange if you haven't seen that s to the minus 1 before. You can just think of that as meters cubed over s. You know, when you bring the s up here, it becomes an s to the minus 1. That's all it is. It's just meters cubed per second. So find the rate of change. Well, you just worked out a formula for the rate of change. That's what dv dt is. So t equals 1, just put that into the formula, and you'll get dv, here we go, dv over dt is equal to 3/4, I've done that again, 3/4 of t squared, well 1 squared is just 1, so times 1, minus 3. Which is simply equal to 3/4 minus 3, which again is equal to minus 9/4. And then, terribly important, put the units back in there. Some examiners take marks off for that, so be careful to put that in, meters cubed per second. So, that's your answer for the next one. Not too difficult, I don't think. Hope you're not finding it too difficult anyhow. So, next one, hence determine with a reason. Hence determine always means look at what you've done already. Whether the volume is increasing or decreasing when t equals 1. Well, you just worked out the rate of change and you worked it out to be minus 9/4. That's what you worked it out to be as, I think. Yes. So, you want to know whether the volume is increasing or decreasing. Well, if the rate of change is negative, then intuitively you're thinking, well, it's going to be decreasing. And you're right, it is decreasing. So all you need to write down is that the rate of change is negative. Therefore, just say that it's less than 0. There you go. Minus 9/4 is less than 0. Therefore, the volume is decreasing. Volume is decreasing. That's all there is to it. 1 mark. Isn't that difficult really for 1 mark? But you just got to learn how to do it, I suppose. So, question CI. Find the positive value for t for which v has a stationary value. Well, stationary value, you've got to know, it's not really intuitive, that one, but a stationary value means that your rate of change is 0, which means dv over dt is going to be equal to 0. Apologies for my handwriting there, but never mind. dv over dt is equal to 0. So what was dv over dt? Well, it's 3/4 t squared is minus 3 has got to be equal to 0. So you can add 3 to both sides, then divide by 3/4 to get t squared is equal to 4. Hope you followed that. And then you've got two options. You've got t equals minus 2, because the root of 4 is 2, or plus 2. And because it asks for a positive value, you've got to say that t equals 2. And that's that. That's 3 marks. Right, next one. Flying through these. Next question. Go for purple, I think. Here we go. Find d2v over dt squared, and hence determine whether the stationary value is a minimum or a maximum value, or a maximum or a minimum. So, to find out this here, d squared v over dt squared, you just need to do exactly the same to your dv over dt as you did in 3 part A. So, you get your 3/4 t squared minus 3, the pen's being a bit funny again, 3/4 t squared minus 3, and you take the power, there's the power, squared, times that by 3/4, which gives you 6/4, 6/4, which you know is 3/2, 1.5. So 3/2 t, 2 take away 1 is 1, so you can put the 1 there, you don't really have to, you probably shouldn't actually. And then this minus 3 gets times by 0, so it's nothing. So 3/2t, and then whether this stationary value, the stationary value you found in the first part, so that's 2, so go 3/2 times by 2 equals 3, and then what you need to say is that 3 there, that is greater than 0. That's how you determine whether it's a maximum or a minimum. If it's greater than 0, this doesn't really make sense, but it kind of does in the bigger picture, but immediately it doesn't make sense. 3 being greater than 0 means it is a minimum value. If it's greater than 0, it's a minimum. If it's less than 0, then it's going to be a maximum value. So this one, 3 greater than 0, let's find a different color, orange. 3 is greater than 0, therefore, it is a minimum. And hopefully you followed that. And I will see you on the next video.